Okay, first of all, here's the warm-up. Take a couple minutes, or however long, work on this, pause and come back. Okay, so back to limits, but I promise the thing we're doing with limits today is fun. It's as fun as limits get. Okay, so first of all, if we just plug -2 into the top one, we end up with 0 over 0. So then what we have to do is rewrite it as the limit as x approaches -2, and we can factor, and this turns into x plus 2 times x minus 2 over x minus 2. These cancel. If you put -2 in there, now we just get -2 plus 2, which is 0. Limit as x goes to 0 of 6 times sine x over x. And we can actually just turn this into limit as x approaches 0 of 6 times the limit as x approaches 0 of sine x over x, which is just 6 times limit as x goes to 0 of sine x over x is just 1. Is that like, I call it the octopus graph, okay? So that's 1. So we end up with 6 times 1, which is 6. So these notes are in the folder if you haven't printed them or looked at them yet, or you can not print them and just take notes. Either way is fine. So we're doing something called L'Hopital's rule. So basically, instead of having to factor when we have indeterminate forms like infinity over infinity or 0 over 0, we get to use a fun little trick. So these are all indeterminate forms here, but the only ones we actually are going to be concerned with is 0 over 0 and infinity over infinity. Okay, so if it's 0 over 0, infinity over infinity, or it could be a negative somewhere, we will get to use L'Hopital's rule. So essentially, if we have a quotient and we get 0 over 0 or infinity over infinity, we get to take the derivative of the top and bottom and try it again. So for example, looking at example number 1, if we put a 5 on the top and bottom and plug it in, we get 0 over 0. But instead of factoring, we just get to say, well, this is actually equal to the limit as x approaches 5. Derivative of the numerator is 4x minus 9. Derivative of the denominator is just 1. So we get to just plug in here 4 times 5 minus 9, which is 20 minus 9, which is 11. Much faster than factoring too. Over here, example 2, same sort of idea. You will get 0 over 0 if you plug in -5. So instead, we'll have to take the derivative of the numerator and the denominator. So this is the same as 4 minus x to the 1/2. So then the derivative of the numerator is 1/2 times 4 minus x to the -1/2 times the derivative of our inside, which is the derivative of 4 minus x, which is -1. The -3 just goes to 0. Derivative of the bottom is just 1. So we'll rewrite, not taking the derivative again, just simplifying. We end up with 1, actually -1, right? -1 over 2 times the square root of 4 minus x, since 4 minus x to the 1/2 is the same as the square root. We put in -5 now, we get -1 over 2 times the square root of 4 minus -5, which is 9, which is -1 over 2 times 3, which is -1/6. Sometimes you have to use L'Hopital more than once. So the limit as x goes to -infinity. Well, -infinity squared is infinity. E to the negative infinity is just e to the infinity. E to the infinity is still infinity. So we get our indeterminate form. So we can take the derivative on top and bottom. The limit as x goes to -infinity. Derivative of x squared is 2x. Derivative of e to the -x is e to the -x times a -1, because the derivative of -x is -1, so I'm just going to put the negative there. Well, this is -infinity over negative e to the negative negative infinity, which is negative e to the infinity. So this is essentially infinity over infinity because the negatives will cancel. So we get to take the derivative again. So now we have the limit as x approaches negative infinity of 2 over negative e to the negative x times another negative 1, which is the limit as x approaches negative infinity of 2 over e to the negative x, which is 2 over e to the negative negative infinity, which is 2 over e to the infinity, which is the same as 2 over infinity, and 2 over a really big number is just 0 in terms of limits. So as x goes to negative 2, we will end up with 0 over 0. If you plug that in right now, evaluate, I guess, to be mathier. I tend to say plug in, even though, it's not that mathy. So we'll take the derivative on top and bottom. Derivative of x cubed is 3x squared. Derivative of x squared is 2x. And then we have minus 8 over 3x squared plus 16x. Hate it when I do that. Plus 16x plus 20. Guess what? We still get 0 over 0. So we take the derivative of again. I said of again, that's not what I meant. Derivative again. So we get 6x plus 2 over 6x plus 16. Now we can put in negative 2 and we get negative 10 over 4, which is negative 5 halves. Sorry, didn't move something I didn't mean to move. Okay, now we got some more. So the limit as x goes to 0 of sine x times 1 minus cosine x over x squared. Well, here, if we put in a 0, sine of x is 0. 1 minus cosine of 0 is 1 minus 1, so that's also 0, over 0 squared, which is 0. So we get to use L'Hopital. Limit as x approaches 0. Excuse me, we're not doing h's. So we'll take the derivative. So product rule on the top. So derivative of sine, which is cosine x, times 1 minus cosine x, plus the derivative of 1 minus cosine x. 1 goes to 0. Derivative of negative cosine is a positive sign, times sine x. So this was f prime g plus g prime f. And then derivative of the denominator, derivative of x squared is 2x. Simplify this a little bit. We get cosine of x minus cosine squared of x plus sine squared of x over 2x. If we evaluate here, cosine of x is 1. Cosine of x is still 1, so we have 1 minus 1 squared, which is 1 minus 1, 0, plus sine of 0 is 0 over 0. Well, basically it's 0 over 0 again. So the limit as x goes to 0, we'll take the derivative again. Derivative of cosine is negative sine x. Derivative of cosine squared x. Remember, cosine of x, cosine squared of x looks like this. Sine squared of x looks like this. Derivative of cosine. So we have minus 2 times cosine of x to the first power times negative sine x. Derivative of sine squared is plus 2 times sine of x to the first power times cosine of x. This is all divided by the derivative of 2x, which is 2. Now, if we put in 0, we end up with, this is 0, this is 0, this is 0. So everything will go to 0, so we end up with 0 over 2, which is 0. Oh, I almost skipped one because I kind of went all over the place in there. All right, let's look at the limit as x goes to 1 of ln of x minus x plus 1 over e to the x minus e. So natural log of 1 is 0. 0 minus 1 is negative 1 plus 1 is 0. And then our denominator, e to the 1 is just e minus e is 0. So we get to use L'Hopital. The limit as x approaches 1. Derivative of natural log is 1 over x. Derivative of negative x is negative 1. Derivative of e to the x is e to the x. And then we have constants, so that 1 on the top goes away. E is just a constant. It's like 2.17 or whatever. Okay, so that goes to 0 as well. So now what we end up with is 1 over 1, which is 1, minus 1 over e to the first power. This is 0 over e, which is just 0. Couple more. So if we evaluate top and bottom here at infinity, we get infinity over infinity, so we get to use L'Hopital. So the limit as x approaches infinity of 9x squared plus 10x minus 3 over 12x squared. That's still infinity over infinity. So let's do it again. The limit as x goes to infinity of 18x plus 10 over 24x. That's still infinity over infinity. I mean, like infinity plus 10 is still infinity, right? Let's do it one more time. Limit as x approaches infinity of 18 over 24. We don't have any variables left. We just have 18 over 24, which simplifies to 3/4. Last one that I'm going to show you. If we evaluate at infinity, top is definitely infinity. E to the 2 infinity is definitely infinity. Natural log of infinity, okay? So now we'll take the derivatives. The limit as x approaches infinity. For the numerator, we get 8x minus 3. Denominator, we get e to the 2x times 2, because we have to take the derivative of the 2x, plus 1 over x. So top's infinity, bottom is infinity plus 0, because e to the 2x is going to be infinity. 1 over infinity is 0. So this is still just infinity over infinity. Differentiate again. The limit as x goes to infinity of 8 over e to the 2x times 2 times another 2. So 1 over x is the same as x to the negative first. So the derivative of x to the negative first is negative x to the negative second. So now I'll simplify. We're not differentiating again. We get 8 over 4 e to the 2x minus 1 over x squared. So what we end up with is 8 over 4e to the 2x, 4e to the 2 infinity is infinity, minus 1 over infinity is 0. 8 over infinity, 8 over a really big number, any constant over a really big number is 0.